Did you know that every time you touch something, you leave behind an invisible fingerprint? These latent fingerprints have revolutionized forensic science, helping solve crimes with remarkable accuracy. Good morning, everyone. My name is Chahak Agarwal, and today we'll explore how forensic experts develop and analyze these hidden clues using advanced chemical, physical, and optical techniques. What are latent fingerprints? Latent fingerprints are invisible impressions left by natural oils and residues on our skin. These hidden clues are unique to every individual. No two people share identical fingerprints. With over 150 years of fingerprint evidence in criminal investigations and 100% unique identifiability, they remain one of the most powerful tools in forensic science, helping us identify suspects with remarkable accuracy. Development methods. Forensic experts employ three main categories of development techniques. Physical methods use invisible particles to develop prints on accessible surfaces. Powder dusting remains the most widely used technique. Different powders work on different surfaces. Black powder on light backgrounds, white or grey powder on dark surfaces, and magnetic or fluorescent powders for multicolored backgrounds. Success requires a delicate touch with soft brushes or magnetic wands, always working from the edges towards the center of the suspected print area. This prevents destroying evidence through excessive pressure. Chemical methods. They work on both porous and non-porous materials. Ninhydrin development is highly effective on porous surfaces like paper and cardboard. It reacts with amino acids and fingerprint residues over 24 to 48 hours to accelerate the reaction. Physical developer uses silver nitrate to develop prints on previously wetted surfaces, particularly effective on documents. For non-porous surfaces, iodine fuming vaporizes iodine crystals to reveal brownish prints. But the most sophisticated is cyanoacrylate fuming, the superglue method. This process occurs in a controlled chamber where fumes bond with fingerprint residues, creating white deposits. The controlled environment manages temperature and humidity to optimize the fuming process, typically lasting 12 to 30 minutes. Enhanced visibility follows as the print appear against darker surfaces. Visual applications include flexible tubing that allows for consistent carbon deposition and creates hard white matrices following the rich pattern. DFO, difluoroderivative, is also powerful, making fingerprints visible under specialized lighting, particularly effective on alternative light sources. Optical methods use advanced imaging without physical contact. Alternate light sources or ALS use high-intensity lamps with specific wavelengths to excite fingerprints invisibly to the human eye. Laser detection systems employ FM wavelengths like argon and helium-cadmium lasers for exceptional precision and control. UV and IR imaging captures fingerprints outside visible light spectrum. Studies show remarkable results. Optical methods achieve 85% effectiveness rate on multi-surface materials, while enhanced detection methods improve traditional results by 30%. Best practices and quality assurance. Professional fingerprint development requires strict adherence to best practices. Always photograph reference surfaces before enhancement, use distilled water where necessary, and perform microscopic examination of all prints and controls. Recorded control procedures ensure accuracy, while malicious documentation preserves evidence for legal proceedings. The future is here. Emerging technologies combine chemistry with digital innovation. Hemline microscopy detects trace enhancements with greater sensitivity and selectivity. Mass spectroscopy and chemical profiling of latent residues, advanced detection, and AI-powered machine learning automation analyzes prints with enhanced accuracy. 3D imaging optimization creates topological analysis for more accurate categorization and identification. Real-world success in statistics. How effective are these methods? Case Study 1. The museum heist recovery. Latent fingerprints from a display case led to recovering artifacts worth millions. Case Study 2. The cold case breakthrough. Physical fingerprints from a weapon decades after identified a suspect. Case study 3. The counterfeiting operation. Prints on documented linked multiple suspects across jurisdictions. The number prove it works. 67% of solved crimes show print evidence, and 92% of cases with admissible fingerprint evidence result in successful prosecution. This demonstrates why fingerprint analysis remains the gold standard in forensic science. From powder dusting to cyanoacrylate fuming to cutting edges optical imaging, fingerprint development has evolved into a sophisticated science combining traditional techniques with modern technology. These methods continue to solve crimes and deliver justice. Thank you.